Yes, good morning guys to all of you. I welcome you all on this wonderful platform that is BYJU'S exam prep. So guys, please tell me quickly, are we ready for the examination, or you can say the questions? We are going to discuss today ISRO previous year paper that was there in 2020. So last ISRO paper was conducted in 2020. As you know, after that COVID came. So after that no paper came. Now the paper will be coming. Am I properly audible and visible, guys? Please tell me that. Yes, guys. So now we are starting the session, guys. So as already told, today the entire complete mechanical team will be here in front of you, and we will be solving the entire last year paper where all the subjects will be covered. So me, Abhinav Negi sir, Suraj Gopi sir, Chandrasekhar sir, together we will be covering the complete paper. Yes, great. Rohit, hello dear. So guys, now we are starting the session without wasting the time. So guys, this is some detail about me. I am having around 10 to 11 plus years of experience, written many research and review paper for those who are watching me for the first time. And guys, there is a workshop on 26th of May at 7:30 p.m. Those who are looking for preparing for GATE 2024, for them it is going to be a complete roadmap to conquer GATE 2024, will be taken by Abhinav Negi sir. So you guys can register it for free. Okay, moving further. So guys, okay, we will be starting from this question. So we are having all the questions of last year ISRO paper. The very first question in front of you is from production. I will be taking care of theory of machines, machine design, production, all these subjects. Okay. Similarly, other faculties will be coming for other subjects, and entire paper will be covered. So guys, high sports facts. Let us start with the first question. During turning of a metallic rod at a given condition, the tool life was found to decrease from 100 minutes to 25 minutes. By looking at this word tool life, you must have get an idea. That question is from Taylor tool life equation. So 100 minutes to 25 minutes is the reduction when cutting speed is increased from 50 to 100 meter per minute. And they are saying how much will be the life of two lift machine at 80 meter per minute. By looking at the question, you must have an idea that it is the lower level of GATE questions. Yes. So guys, this is the type of question which is coming in ISRO. And if you see the ISRO paper, this is the highest level of question which they have asked in production. Okay. Yes. So very good. I am giving you the formula Vt to the power n is equals to constant. This is a Taylor to life equation. So as you are given that 100 minute to 25 minute, you can say that T1 is 100 minute, T2 is 25 minutes, and you can say velocity V1 is given as 50 meter per minute, and they have given V2 as 100 meter per minute. So this data have been given to you. So you can apply V1 T1 to the power n, V2 T2 to the power n. From here you can find out the value of n. After getting it, you can apply V1 T1 to the power n is equals to V3 T3 to the power n, because they are asking the tool life for 80 minutes. They are asking the velocity for 80 minutes of tool life. So T3 is given as 80 minutes. You need to find out V3. I will be giving you the hints. Solution you have to do. Yes, Ashrit. So I will be waiting for your answer. That what will be the right answer for V3. These are the four options in front of you. Yes, guys. And do like and share the session, guys. We are the first one to come up with the solution for your ISRO examination. And we will be covering all the previous year's question one by one. Parth is saying the answer is going to be A. Okay, what about others? First tell me the value of n. Okay, now Parth is saying the answer to be B. First tell me what is the value of n you are getting, guys. Yes, Ashrit, Ashok, Pajal word. What would be the answer? Guys? Quickly tell me, quickly. I am waiting for your answer. Very good, Parth. the value of n will be coming out to be 0.5. So when you will solve, velocity will be coming out to be 39.06 minutes. So answer for this question is going to be B. Very good. Very good, guys. Moving to the next question. Moving to the next question. Very good, Prandtl word. So answer will be B for this question. So guys, there are some numerical, but majority of the questions are theoretical as well. This is a question from rolling. This is also once again the question from production technology. You can see the question in a single pass rolling operation. The thickness is 100 mm. Okay, thickness of a 100 mm wide plate is reduced from 20 to 15 mm. So you can write H0 as 20 mm and H1, that is the final thickness, as 15 mm. So you can say delta H, that is the draft, is 5 mm. Then he is saying the roller radius is 125 mm. So you are getting to know the R as 125 mm. They have given the rotational speed as 8 RPM. The average flow stress for plate material is 400 MPa. You need to find out the power. I feel everybody would be aware of that power can be written as torque into omega. है ना? And you know omega is nothing but 2 pi n by 60. 2 pi n by 60. Then my dear, you need to talk about the torque. And if you remember, torque in case of rolling operation, we are having actually two rollers. So first of all, when we need to find out the power, here because there are two rollers, generally power is given as 2 times T into omega. So when we are talking about the value of torque, you are aware that if this is the center, the net roll separating force is passing at a distance of A from the center. So that is why we are writing torque is equals to F into A. And this A is said to be the arm length. It is said to be lambda into L, where L is given as square root of R delta H. Okay, I feel everybody would be aware of this formula. And you need to find out now what is the value of F. So when friction is not given, coefficient of friction is not given, then you have applied a very simple formula for this. If you remember, you know force is given as the average or mean flow stress into width into arc. Which arc? This arc on which this roll separating force is acting. This is said to be L only. So it is once again B into L. L formula is there in front of you. You will apply the formula, get F, get T, and then find out the power. This is how you can solve it. I have given you, yes, very good, Prandtl word. What will be the answer for this question? Solve it, guys, solve it. I want answer from all of you. Parth, Prandtl, Ashrit, just solve it. I'm sharing it, guys, and you also please share the session, like the session, so that other student will also join us. More the number of students will join us, you will be getting benefited more and more. So just try to solve it. Try to solve it. Yes. Everybody, what would be the answer, guys? Okay, one by one we can find out. First of all, try to find out this force. You can see the width is given as 100 mm. So average stress is nothing but 400 MPa into width is 100 mm. And L value will be R delta H. You need to just put these value and you will be getting the answer. Yes. Okay, definitely Parth, calculate it. Actually, not more than 8 to 10 questions are of this type. All other questions are theoretical only. So 8 to 10 questions are having this type of calculations. Okay. So whenever you will be giving the exam, try to do these type of questions at the end, which are having heavy calculations. Solve the theoretical questions, one-liners in the initial phase. Whenever you go for the first round of reading of paper, easy question, you can just do it like that. After that, whenever you come with numerical, go for the numericals, you are aware of which formula will be there. And at the end, you do those questions where you have lesser idea, or you are going to use some guess kind of thing or some intuition kind of things. Okay, so this is how you need to approach the paper. So one by one, guys, you can solve it. I have given you the formula. This is basically from the topic rolling, which is metal forming part. And you can say in other words, it is the part of production technology. So 7 to 8 questions are from production. 7 to 8 questions are from material science. So this will give you an idea that material science is having high weightage. Okay. Yes. Parth, Ashok. Ashok, are you solving or not? Rohit, are you solving or not? Ashrit, you are just giving the formula or solving also? Pagel word. Are we trying? And don't worry, all the subjects will be covered. So I am right now taking care of production, theory of machines, material science, okay, machine design. Then Abhinav sir would be coming for maths and so on. Then Chandrasekhar sir will be coming for fluid mechanics, thermodynamics, RAC, IC engine, power plant. Then Surya sir would be coming for engineering mechanics, for industrial engineering, for heat and mass transfer. Yes. So guys, every question of the exam will be solved in front of you here. So just solve it and get the answer. Okay. So if you want some help of mine, I will give you an idea that when you will be finding out the value of force, you will be getting it as 1000 kilonewton. This will be the value of force you will get. Then you need to find out the arm length. Lambda will be considered to be 0.5. You know that, I already told you many times. When you will put this, you will get the value of A to be 12.5 mm. 12.5 mm. Now you just need to put the values and get the answer. Yes. Parth, Ashok, Pejal. They are easy questions, just lengthy you can say. And only 8 to 10 questions are like this. Yes, guys. Great. So guys, when you will solve it and put all the values, then the answer you will be getting is going to be very good. Parth have given 40 pi by 3. Dear, I feel you have done some calculation mistake. The answer will be coming out to be 20 pi by 3. Some calculation हड़बड़ी में आपने गलती कर दी लगता है, because you have not taken the value of lambda, I feel. Okay, when you will take lambda 0.5, the answer will be 20 pi by 3. Okay. Yes, Pejal word. Okay, everybody is getting 40 pi, then maybe my calculations are wrong. Okay. Maybe this, whatever I have written, is the value of t into omega. When you will multiply by 2, then you will get 40 pi by 3. Okay, then it's fine. Whatever I calculated is t into omega. 40 pi by 3 is fine. Or I have made it correct? Tell me that. Okay, I feel someone is Dukhi Atma. Okay. Dukhi Atma is saying I am correct. Okay. So answer is 20 pi by 3. Lock kar de isko. Shall we lock it? Shall we lock it, guys? Lock kar diya jaye. Yes, D is correct. So 20 pi by 3 will be the right answer. Okay, guys. Moving further, now you can see easy questions are starting. So difficult, lengthy questions are over. Now easy questions are starting. In small casting, which of the following allowances can be ignored? Option A, shrinkage allowance. Option B, wrapping allowance. Option C, draft allowance. Option D, machining allowance. Now these type of questions are many. As I said, numericals are 10% only. So those 10% are lengthy, but all others are very easy. Now everybody can see and get the answer very easily. Yes. Dukhi Atma, if I am not wrong, maybe you are Gajendra. Sorry, Gajodhar. Yes, Parth, Pejal. Okay, B. Dukhi Atma is saying B is the answer. Pejal word is saying B is the answer. Okay, so guys, here I would like to tell you, first of all, shrinkage allowance and machining allowance. These two are independent of size. These two are independent of size. Okay, and wrapping allowance is there in every casting. Every casting. It cannot be ignored. Ignorance can be done with the draft allowance. For small size of casting, the chances of rubbing of walls are very, very less. So this can be ignored for the small size casting. Because wrapping allowance is required, otherwise you will not be able to take the workpiece out. So the answer of this question will be C. So I feel Arnab have given the right answer. Moving further to the next question, this is once again numerical from arc welding. Numerical from arc welding. And if you will see the exam, they have aligned the questions together. Parts, if you remember when we are going for the casting, like this is a mold. This is the pattern. So whenever you want to take the pattern out, to take the pattern out, you are going to apply the forces here. You are using a hammer of wood and applying forces here. Because of this, the sand near to it is going away from the pattern. Then you take the pattern out very easily. So this allowance is said to be wrapping allowance because you can see the cavity size have been increased because of that. Okay, I feel you got it. Now the next question, guys, is from arc welding. Solve this question now. In an arc welding process, two weld coupons were made using two different welding processes. For the first coupon, the voltage current welding speed are 15 volt, 300 amperes and 30 mm per minute. 30 mm per minute. This they have given. Second setup is saying 60 kilovolt and 200 milliampere and 25 mm per second. You need to see the units. Here it is in minute, here it is in second. If the heat transfer efficiency in the first coupon is half that of second, means if this is first process, this is 2, then in the second is half that of first. I feel it is opposite. Efficiency in second, efficiency for welding in the first is half that of second. So you can write efficiency of 1 is efficiency of 2 by 2. Forget about this. Now, my dear, I feel you know the formula for heat supply. V into I into efficiency divided by V. This is the formula for joule per meter. Okay, this is the heat supplied in the units of joule per meter. So voltages are given. You just need to say what? They are saying that the ratio you need to find out. The ratio of heat input per unit length is. So you need to find out the ratio. So just try to find out HS1 by HS2. Okay, that ratio you need to find out. Formulas are there in front of you. So what you need to do here, V1, I1, efficiency 1 by V1. Then V2, I2, efficiency 2 by V2. And before putting the value, convert this also into mm per second so that you get the right answer. Solve this question very easy in front of you guys. Dukhi Atma, solve this and get the answer. Arnab, I am expecting right answer from you. So Arnab, Parth, everyone guys. So after these questions of production, MD and Tom, Abhinav sir would be coming with the question of SOM and maths. After that, Chandrasekhar sir. And then after that, Suraj Gopi sir. So entire team will be in front of you. So guys, just share the session everywhere, because that opportunity you will not get anywhere else, that we are coming up with the previous papers in front of you. Yes. Solve it, solve it, solve it. Yes. What would be the answer, guys? V1 is 15. I1 is 300. Efficiency of 1 is efficiency of 2 by 1. Keep it as efficiency of 1. V1 is 30 mm per minute. We will divide by 60. It will be 0.5 divided by. Second data is 60 into 10 to the power 3. Then 200 into 10 to the power minus 3. Then efficiency of 2 is 1 is okay. 2 is 2 times of efficiency of 1 divided by 25. Okay, Pajan is and Parth is saying D will be the answer. Yes, Dukhi Atma, what is the answer? Yes, yes, yes. Tell me. Parth and Pajan, have you converted that into mm per second? So when you will be doing that, 30 divided by 60, it is 0.5 mm per second you will get. Have you done this? Please tell me. Please confirm, yaar. At least be interactive. If you have made some mistake, we will rectify this. Yes, Parth and Pejal. Have you done this thing? Have you done this thing? Fine, fine, fine. Okay, but the answer is what Dukhi Atma is saying. B. This is the right answer. And this is from the ISRO keys, and I have also solved it. 75:8 is the right answer. So Parth and Pejal, you have done some calculation mistake. But don't worry, don't worry. This is not the final paper. This is the place where we can improve upon. Okay. So that is, you need to see where you are making the mistake. So in calculation, you need to work more. But as I said, these types of questions are very less in number. To make it more and more interesting, I have kept these questions first. Otherwise, majority are theory question. Like this question, very easily you will answer. This question is saying, in gas tungsten arc welding, which of the following polarity is generally used for getting higher penetration? Mark this word, higher penetration. For higher penetration, we need more heat in the workpiece. For higher penetration, we need more heat in the workpiece. So if you are having a workpiece like this, we will be requiring more heat in the workpiece. For that, workpiece will be made positive. So which polarity is that? Which polarity is that? Yes, Parth, that's why I asked. Direct current straight polarity is the correct answer. Very good. A is right. A is right. A is right. Very good. So this is how you need to answer in the paper, because these types of questions are more in number. Moving to the next question. This is, okay. This is 4-bar linkage theory of machines question. Gray-Schoff law. Let us see how many of you give the right answer. Gray-Schoff's law. I already told you, very important law every year comes in the paper. But before you answer, you can see they are talking about triple rocker. Triple rocker or double rocker, they can say. So whenever you have double or triple rocker, what should be the condition you must be aware of? Very good, Dukhi Atma. Yes. Dukhi ko sukhi kar lo bhai. Yes. What will be the answer for this? Mind it. They are asking triple rocker. you can consider it double rocker. For double rocker, what would be the answer? Very good. So the answer will be this, because for double rocker or triple rocker, it is required that low shall not satisfy. Grashof law says that if S plus L is less than equals to P plus Q, you will be getting at least one crank. When you will get one crank, then mechanism cannot be double or triple rocker. So to get double or triple rocker, we need that law shall not be satisfied. So answer B will be correct one. Okay, here law is satisfied, so wrong. Here law is okay. Here the things are not written in proper way. Moving further, next question is from kinematic analysis of single slider crank mechanism. So the piston of an engine moves with a simple harmonic motion. This is a cylinder. This is a piston. Connecting rod crank given to you. They are saying that the crank rotates at 120 RPM. N is 120 RPM. From that you can find out omega 2 pi n by 60. Then my dear, with a stroke of 2 meters, so you know that when they have already mentioned the stroke of 2 meters, then stroke can also be written as 2 times of radius of crank, which is given as 2 meters. So radius will be 1 meter. The velocity of the piston, that is r omega sine theta plus sine 2 theta upon 2n, if you remember. But they have not mentioned, they have said it is at a distance of 0.8 meter from the center. Okay, 0.8 meter from the center, they are saying. So they have not mentioned anything about L and R. R we know that 1 meter, but L not known to us. So without that we cannot move ahead because N is not known. For such case we will say N is very, very large. So when N is very, very large, this term will be neglected. So we just need to find out the theta now. Now my dear, as N is very, very large, when you write the formula for displacement, it is R, then R, it is, if you are going to write down the X, it is, you know that if we are saying this is the extreme position, this is the movement of piston X, then I feel everybody would be remembering the formula. It is 1 minus cos theta plus N minus N square minus sine square theta. Then you know N is very, very big. So in place of N square, sine square theta will be ignored and N will get cancelled out. So this entire term will become 0. So you will get the answer as X is equals to R into 1 minus cos theta. And as they have said 0.8 meter from the center. So you know from here to here total is 2 meter stroke length. Then if from the center we will talk about, this should be 1 meter. And they have given it is 0.8 meter from the center. So displacement is 0.2 meter. 0.2 is R into 1 minus cos theta. From here you can get the value of theta. After getting theta, you can find out the velocity of piston. This was a wonderful question. I am sometimes surprised that 8 to 10 questions in ISRO are coming even beyond the thinking of strength of paper of gate. But rest questions are so easy that anyone can answer. So dear, the first thing in the ISRO paper will be to choose your type of questions. Okay. Dukhi Atma, actually that is misprinting. B will be the right answer because in ISRO it is MCQ only. So D was a misprint, don't worry. In the previous question, D and B both are same, so you can say both are correct. It was a misprint actually, here less than sign will come. Then it will become wrong. Solve this question, guys. Yes. So Pagel word, are you giving the answer for this question as A? Solve it properly, guys. I have seen in calculation type of questions, you guys are not giving the right answers. Dukhi Atma, be fast. 4.8 pi, 2.4 pi, 12 pi, what will be the answer? Arnab, where are you? Next question is from Coriolis component. Tell me the value of cos theta. Ha, Parth, but note it. The point is, if you are able to make 70-80% question correctly, no need to go for any such question where you have doubt. Can you tell me from here what is the value of cos theta? Cos theta, this is R is 1 meter, 1 minus cos theta. What will be cos theta? Cos theta will be, very good, Dukhi Atma have given the right answer. Yes, 2.4 pi will be the right one. Pagel word, once again you have made the mistake. You can see it, 0.2 is R into 1 minus cos theta. 2 times of R is 2 meters. So R will be 1 meter. So from here you will be getting the value of cos theta as, you can say 1 minus 0.2. Okay. So you will be getting from here cos theta is 0.8. So once you get cos theta, you can find out sin theta. You know sin theta will be what? If 0.8 can be written as 4 by 5, then sin theta will be 3 by 5. So if that is 3 by 5, it is 0.6. So when sin theta is 0.6, R is 1, omega can be found out. Answer will be 2.4 pi. B is correct. Very good, Ashrit. Very good, Ashrit. So, okay, cos theta is 0.6. I feel I have done it correct. Yes, cos theta is 4 by 5, sin theta is 3 by 5. Answer is 2.4 pi. Arey bhai, this is 0.2 na? X is 0.2. R is 1 meter. 1 minus cos theta. When cos theta will be going there, you will be getting 1 minus 0.2. Okay, so I have written it correct only. B is the right answer. Very good, Dukhi Atma. Now you got it. Pagel, now you got it, your mistake. Very good. So Parth, you guys are getting one more chance. A block slides outward. I am making the figure for this. This is the block. A block sliding outward on a link at a uniform rate of 30 meter per second. While the link is rotating at a constant angular velocity of 50 radian per second. 50 radian per second. They are asking you Coriolis component. I feel everybody would be remembering the formula. Coriolis component is 2V omega. 2V omega. Solve it and get the answer. Solve it and get the answer, guys. Parth is saying C. Pagel word is saying C. Very good. So that's what I said. If some difficult questions are there, some very easy are also there. So when you are going to make the paper, in the first time you will make all easy questions which you are answering just by looking at it. Then you will go for those numerical which you know, which are very small, like this type of numerical. At the end you will go for the numericals like you have seen last one, like you have seen welding numerical, like you have seen forming numerical. Very good. Everybody is giving the correct answer here. C is the answer for this. When you will put it, you will get 3000 meter per second square. Because omega is directly given as 50, velocity is 30, so answer will be 3000. Moving to the next question, very easy one. Look at it. Every question is not difficult and every question have same marks. This question will also give you the same marks what the previous question will. So why to choose difficult question and why to make our journey difficult? Answer this. I feel everybody will give the right answer for this. When the axis of first and last gear are coaxial, this is the axis of first gear, this is the axis of last gear, first gear, last gear. When the axes are becoming same, in which gear train? Which gear train? Yes, it is a reverted gear train. Reverted gear train. Very good, very good. Wonderful, guys. Wonderful, guys. Wonderful. Ashrit, got it or not? Arnab, got it or not? Parth, very good. Pagel word, very good. Moving to the next question, guys. This question is from Gyroscope. You can see in theory of machines how many questions we have seen. So you know for gyroscope the couple is I omega omega p. you need to find out the value of omega p. And they have already given the value of omega to be 20. And they have given the torque is 100 Newton meter, means couple is 100 Newton meter. And they have also given the I value as 1 kg meter square. So just need to find out omega p. Simple formula needs to be applied. They are not even asking about direction. What will be the answer to this question, guys? What will be the answer to this question, guys? Very good, very good, very good. All of you in the one word, B is the answer. Very good. Pejal word, Dukhi Atma, Parth Patel. Very good. B is the right answer. B is the right answer. Moving further. This is once again from the theory of machines. This is which of the following mechanism provides intermittent rotary motion? Intermittent. Yes. For intermittent, only one name is famous. Which mechanism will be used in intermittent? Theory of machines, lower pair mechanisms. Very good, Dukhi Atma. What about others? Ocean, very good. Pejal, very good. This is Geneva. This question have been asked in engineering services many times. I told you that these types of questions from ESC are getting repeated in ISRO. That's why I said PYQ of ESC are important. Moving to the next question. This is from metrology and inspection, surface roughness. Surface roughness. What does A and E indicate here? This is from metrology and inspection. When I taught you the inspection, I taught you all the notations here. Ocean is saying A. Very good, Ocean. What about Pejal? Guys, do like and share the session. I want more students to join live because the number is very less as expected. A is correct. A is correct. Very good. Very good. A is correct, everyone. Moving further, guys, now we are talking about this question. This is from theory of failures. Machine design subject. Theory of failure, machine design subject. We have seen Tom question, many production question. Now we are talking about question from machine design. Steel machine element. Steel machine element at the critical section is in biaxial state of stress. Biaxial state of stress means this. And you know, if this is sigma xx, this is sigma yy. No shear is acting, it will become sigma 1. No shear is acting, it will become sigma 2. And he is saying sigma 1 and sigma 2 are 300. So I feel you are aware for von Mises theory. Sigma 1 square, sigma 2 square minus sigma 1, sigma 2 is SYT square. So you need to find out the value of SYT. This is nothing but von Mises theory. Solve it and get the answer. I have given you the formula. This is for von Mises theory. Theory of failure, machine design. For civil peoples, theory of failure comes in SOM. For mechanical peoples, they have mentioned it in machine design. Yes. And in reality, it should be in machine design only because it is relating the design. But why we study in SOM? Because it is having application with principal stresses. Very good. Everyone have given the right answer. 300 is correct. Because when you will put the value 300 ka square minus 300 ka square. 1 300 ka square will get cancelled out. Answer is 300. Next question is from once again theory of machines. They are saying the natural frequency. For that, first find out the equivalent stiffness. You know that we can also make it like this. K3, K1 plus K2. Because, okay, sorry, not K1 by K2. This is in series. So that can be written as 1 by K 1 by K1 plus 1 by K2. So this K is K1 K2 by K1 plus K2. Now this and this are in parallel. You can find out K equivalent, and omega n will be given as K equivalent divided by mass. Solve it and get the answer. They have mentioned the value K1, K2, K3, 4, 4 and 8. So they are equals to 4. 4 cross 4 by 4 plus 4. This is K3 is 8. So now you know whatever it will come, 4 plus 4, 8. 4 into 4, 16 by 8 is 2. So now K equivalent is 10. 2 plus 8. Solve it and get the answer, guys. Mass is given as 90 kg. What will be the answer for this? What will be the answer for this? Very good, very good, very good. 0.33 is correct. A is the right answer. Pagel word, I feel you have made the mistake. When this is 10, mass is 90. So what you will get here? 10 by 90 is 1 by 3. 1 by 3 is 0.33. Very easy question. Very good, Ocean. Very good, Ocean. Wonderful. Moving further, guys, the next question is this. A metal alloy machine component is subjected to fluctuating tensile stresses from 100 to 200. The material has yield and endurance strength are this. Find out the factor of safety. As they have given the yield strength and endurance. What is yield? What is yield? They have mentioned as 450. Endurance is 200. So whenever they are giving this, only we can go for Soderberg criteria. Because Soderberg need these two things. So you know what we can do now? For Soderberg, sigma mean by SYT, sigma amplitude by SE is equals to 1 by N. You know sigma mean is maximum plus minimum by 2. 100 and 200. Maximum plus minimum by 2. And sigma amplitude is maximum minus minimum by 2. So you know maximum is 200, minimum is 100. Just put the value and get the answer, guys. Put the value and get the answer, guys. Solve it. Solve it, guys. Yes, Dukhi Atma, what will be the answer? Okay, Parth is saying 12 by 7. Dukhi Atma is also saying 12 by 7. And I would like to say that 12 by 7 is correct. So answer for this will be 12 by 7. Maximum plus minimum by 2 is 150. Maximum minus minimum by 2 is 50. Putting the value, you will get 12 by 7. Very good, guys. Dear Dukhi Atma, it will be offline. Till now, they have mentioned it to be offline. Okay, ISRO is always taking offline exam. That's why paper is available. So a driver of mass 100 kg standing at the tip of a springboard of negligible mass. The natural frequency of the springboard with the driver is 1.6 Hertz. What is the static deflection at the tip of the springboard when the driver is standing at the tip? So the point is, you know, omega n is equals to square root of g by delta. They have given frequency in Hertz. So 2 pi Fn is equals to g by delta. So delta is unknown. You need to find out delta. This is Rayleigh method. of vibrations. This question is from vibration. Sir, engineering maths is there. Yes, Parth, actually till last year's every year maths is coming, and maths in this paper have 7 questions. Okay. Yes. Solve it, guys. Solve it, solve it, solve it. Solve this question, guys. So guys, whenever we are talking about ISRO paper, like in the previous pattern, they were giving the time. In that time, paper was not completing actually, because the time is lesser. And if this type of numericals will be there, you cannot attempt the complete paper. So we are expecting that this time they may change this thing, because they have also added the aptitude now, which was not previously they were there to that much extent. Now 20% weightage is simply given to the aptitude part. So that is why I feel this time maybe either questions will be of more theoretical type. So what will be the answer? Dukhi Atma. Fn is given to us as 1.6 Hertz. Fn is known to us, only delta is unknown. Okay, after 5 more questions from my side, then Abhinav sir will come. Parth, we have taken a session on that. There I have mentioned all the details of paper. You can go for that notification session of mine. There everything is mentioned, the syllabus and everything. Okay, yes, answer will come approximate here. The answer will be coming out to be 97.06. So nearby answer is 98.1 mm. C is correct. Pagel word, got it? Very good. Parth, Pagel. Ocean, got it? Ocean. This is from material science now. Theory questions. Which of the following is classified as secondary bond in the materials? Which of the following is secondary bond? This is from chemistry 11th class. Okay. So material science, it is not of material science technical. It is asked from material science of paper 1. That's why I always say that in ISRO examination, ESC syllabus is taken. Because ESC paper 1 part is asked here. Dukhiyatma, but it is for everyone, na? Hydrogen bonding. Hydrogen bonding will be the answer. No need to skip. And you may be thinking they are repeated. Yes, these type of questions are repeating. So what is the benefit of attending these sessions? The same. Now next time when you will see this question, you will not say skip. Okay, that is the benefit. Hydrogen bonding. Next, the number of atoms per unit cell for FCC. For FCC, the average number of atoms. Corner atoms by 8, face centered by 2, body centered by 1. What will be the answer? Very easy question. FCC, BCC, we have done in detail. This is from material science of GATE syllabus. Parth Patel is saying 6. सोच कर बोलो यार. FCC, corner atoms 8 by 8, 6 by 2, 0. What will be the answer? Yes, 4. For BCC, average number of atoms is 2. Simple cubic is 1. FCC is 4. HCP is 6. Okay. Moving further. Next question. So they are saying in a 2-component system, the non-compositional variable is only temperature. Okay, so it means you will use the Gibbs phase rule. P plus F is C plus 1. because only one thing is variable. Number of degree of freedom, that you need to find out. In the case of a single phase, P value is 1 plus F. They have already mentioned that two component system, 2 plus 1. Find out the degree of freedom. Very easy question. Gibbs phase rule. Gibbs phase rule. Yes, very good, very good, very good. Pagel word. Dukhi Atma, this is actually C plus 2 is when temperature and pressure both are variable in thermodynamics. In material size, pressure is constant, atmospheric. So that is why only one unknown temperature. So the formula becomes C plus 1. Okay, C plus 2 is in thermodynamics. There temperature and pressure are variable. Here only temperature is variable. Okay. So the answer for this will be coming out to be 2. So guys, P plus F, C plus 2. Here 2 is for temperature and pressure. So P plus F, C plus 1 in material size, because here only temperature is variable. Pressure is known to us. Great. Moving further. In an iron carbon diagram, the percentage by weight of carbon at eutectoid composition. If you remember, when we are talking in the steam region, then this they are asking. Eutectoid point. Eutectoid point. Up to 2% is steel. Tushar is saying B is the answer. Very good, very good. Dukhi Atma. B is the right answer. 0.76. So you can see these are the questions which will make you in the ISRO. So these type of questions are going to help you. Okay. So every question will not be for you are attempting. Some will be to leave as well. This question is to attempt easily. Very easy question once again from material size. Out of these phases, which of the following is the hardest? Out of these phases, which of the following is the hardest? Martensite, perlite, bainite and spheroidite. Martensite, perlite, bainite and spheroidite. Dukhi Atma, material size is the high weightage subject. Thermal part is the high, your favorite thermal due to Sodhu sir. It is high weightage. Like when Chandra sir will come, he will be having large number of questions. So like engineering services, they are following the trends. ESC takes more question from thermal. So they also will take more question from thermal. So you can say 40 to 45% weightage to thermal, and in the design and production part, more weightage is dedicated to material size, strength of materials, okay. Lesser weightage towards production if compared with the gate paper. Okay, martensite is the more brittle. Very good. Next, which spring steel is widely used in aircraft engine? Now I know this question 99% will not be able to answer, because these type of things are mugging up kind of thing. Okay, so this type of question everyone will not be. Haha Parth, every day you will get one session related to ISRO, that is for sure. And I want you shall communicate this to more and more of your friends so that we get more crowd and we will get benefited everybody. Okay, so then we will be going for all the previous year's paper, some mock test. Previous year's papers are from the previous trend. Mock test will be on the recent trend. Okay, aptitude session, everything we will come up. Chrome vanadium is the right answer for this. Chrome vanadium. Okay, because chromium and vanadium are used majorly in the aircraft application. This is from machine design. Machine design. Notch sensitivity. I feel, yes, notch sensitivity. I feel Chandra sir is also there in between us. Dukhi Atma, that kind of questions you can get only from these sessions. Those cannot be taught majorly in the classes because they are mugging up kind of things. Application. They are repeated question. Like this question also asked in DRDO 3 times. So that you can get from previous year's papers only, which we are coming up with you. Okay. You know node sensitivity factor is KF sigma naught minus sigma naught. KT sigma naught minus sigma naught. KF minus 1, KT minus 1. B is the right answer. Increase in the actual stresses to the increase in the theoretical stresses. Is it clear for everyone? Wonderful, guys. In vibration isolation, omega by omega n is less than √2, then the transmissibility will be. I feel you know that when we are talking about √2, 1, 1, how the graph goes. Everybody remember? When it is less than √2. Less than √2. What will be the answer? Yes, it is greater than 1. C will be the right answer, greater than 1. Wonderful, guys. Wonderful. Next question, guys. So after this, we have 1 to 2 more questions. Then Abhinav sir will join us. So I am calling to Abhinav sir so that he will be ready. Just solve this question, guys. Just solve this question. So guys, just after 2 questions, Abhinav sir will join us. So be ready. Okay, sir. So Abhinav sir is already ready. I just talked to him. You just solve this question, guys. After this 1 more question, then Abhinav sir will join us. Solve this question, guys. The natural frequency of a simply supported beam. Simply supported beam of mass m and length L at its center. Simply supported beam of length L with mass m at its center. Okay, at its center we have mass m. So mg will be the weight. And flexural rigidity is EI. So you know that for this, what is the deflection? Deflection here is, if this is P, PL cube upon 48 EI. P will be mg. So you know Rayleigh method says this is G by delta naught static deflection of mass. So keeping that into mind, you can answer, and if you want Fn, you shall write 1 by 2 pi G by delta naught. Very good, very good, very good, Dukhi Atma. Soon you shall be Sukhi Atma. Yes. What will be the answer, guys? Just by looking at the options, you can answer it. Only one option which is matching with the data. Yes, everyone. Do like and share the session, guys. हाँ भाई, पेजल वर्ड, दुखी आत्मा, what will be the answer? Fn 1 by 2 pi G. This is the static deflection of mass. Yes. So when you will do this, answer will be A. Okay, so 48 EI, because when you will put it here, mg L cube upon 48 EI, A will be the right answer. Last question, guys, in front of you. Last question in front of you is this. A machine component of natural frequency 20 radians per second. Omega n is 20 radians per second. Subjected to base motion from the machine which is harmonic in nature with amplitude. Okay, acceleration 3 meter per second square. At omega is 10 radians per second. What is the peak amplitude? You know, A formula is, what is the amplitude given as? What is the formula for amplitude is? You know, it is F naught by S 1 minus R square plus 2 zeta R ka whole square. You know, here zeta will be 0. So this term will go into null. Amplitude can be written as, here it is F naught, I can write it F naught by M into M by S, and it is 1 minus R square ka square root. Square will get cancel out. You need to find out the amplitude A. You know, it is F naught by M can be written as acceleration. Acceleration is 3 meter per second square into M by S can be written as 1 by omega n ka square. 1 minus R is omega by omega n. Put the value, get the answer. Last question. Then Abhinav sir will join. Very good. So what will be the answer for this question? Calculative once again. But we are expecting this time calculative question should be lesser. In mechanical paper, more calculative questions are asked. And that is why cutoff is lesser. If you compare with other branches, cutoff is lesser because in other branches, they are more theoretical asking. 10 mm is correct. Very good, Tushar. So guys, now I would like to say from my side, goodbye. Then Abhinav sir will be joining. After Abhinav sir, Chandra sir will be joining. After Chandra sir, Suraj sir will be joining. So maybe in next 1 to 1.5 hours, it will be completed. And every day we will be coming up with the previous year's question or mock test for you guys to make your preparation more and more better. Okay, so goodbye from my side and just continue with the paper.
Hello everyone. Guys, just quickly confirm me that my audio video is fine. Everyone on the comment section. Okay, fine. So directly from Hisar to Delhi. So Dheeraj sir is taking class from Hisar and now in the same link I am here from Delhi. Sir has taken the design subjects. Now I will be taking strength of materials and mathematics. That is the previous year question of 2020. Then Chandrasekhar sir will be coming with his subjects like fluid mechanics, HMD. Then Suraj sir will be coming with his subjects TOM and all. Okay. So 2020 complete ISRO PYQ is done today in this session. And guys, what about other sessions? What about the session of the or the previous year papers before 2020? That will also be done in this channel only by all of us. Okay, so guys, keep sharing the session so that more and more commandos can join in. Dheeraj sir has taken the session. Now I am coming with SOM and mathematics. Then Chandrasekhar sir will be coming just after me, and then Suraj sir, all in this session. If I tell you about the cutoff, okay, if I tell you about the cutoff usually when the paper was out of 240 marks, then for undeserved category the cutoff was approximately 137, 120 like this. Now this time the paper is of 100 marks, as Suraj sir has told you yesterday. The cut and number of seats for mechanical is largest among all the branches. So cutoff is expected around 68 to 72 for written exam. Then you will be shortlisted for interview. Okay, the difference from the last year ISRO exams and this time, the age limit has been decreased to 28 years. Second thing, guys, earlier once you qualify in the written, then only on the basis of interview your final selection is depending. Written marks are not counted. This time written and interview, both weightage will be taken. Guys, if you want to see the complete workshop of the roadmap to conquer GATE 2024, you can join me today on app. That is 26th May at 7:30 p.m. Today on app, 26th May at 7:30 p.m. Guys, this is the Super Saturday. Okay, this will be coming now every Saturday from tomorrow onwards. The sessions will be there where we will be telling you either about the legends or the Raftar. You can join me in my Telegram group, Civil by Abhinav sir. Let us begin the session. Okay. Now, guys, of course, the time required for solving a question in ISRO is much lesser than the GATE examination. GATE examination 65 questions, 180 minutes. Here it is 1:1 ratio almost. So some simple questions that easier than the GATE is expected. So now the maximum shear stress in rectangular section is 3/2 of tau average. So what they are asking? They are asking what is the ratio of maximum? Tau max by tau average. So this is 3/2. And guys, this 3/2 is same for triangle and rectangular. Here the tau max is 3/2 of tau average. For circular it is 4/3 of tau average. Okay, everyone, yaar. Pejal, Dukhi Atma is very from here. Thank you. Now the next question. The maximum for the bending moment at mid-span is asked. Let this be RA. Okay. Let this be RC. Guys, movement about any point has to be 0. Movement about any point has to be 0 for equilibrium. I'm not saying bending moment may or may not be 0, but movement will always be 0 at every point. So from here, RA into 2 clockwise, then 4 into 1 downward load, and it will produce an anti-clockwise movement. 4 into 1.5, that is 6. So RA value is equal to 3. RA value is equal to 3 Newton or kilonewton, whatever. Have you got this? Everyone, please let me know, yaar. Come on. Have you got this? Okay. Now, if I want bending moment at B, here, see from left hand side, applying the sign convention of bending moment, RA, upward load positive, 3 into 1, minus this total load is 4 into 1 is 4, acting at center of mass, that is 0.5. So 3 minus 2 will be 1. A option. Yes, DA. Yes, DA. Excellent. Next question. Cylindrical pressure diameter दे रखा है, thickness दे रखा है. Okay. And if there is cylindrical pressure vessels and if the gas is inside, so of course these members will be stressed. Now, what is subject to internal pressure? Hoop stress is PD by √T, and axial means longitudinal stress. That is PD by 4T. Now pressure is given, diameter is given, thickness is given, everything is given. Just you have to put the values. So this will be D option. Have you got it? See, we want PDT. So pressure is given, diameter is given, and thickness is given. Now don't want to waste time here. Let's just go to the next question. Everyone, for a long cylinder column, uniform cross section, ratio of critical buckling when both are hinged. So when both ends are hinged, when both ends are hinged like this, upon PCR, when both ends are clamped, that is fixed, like this. Now if I don't know any formula of L effective and all, I will tell that this is a weaker one, this is a stronger one, so ratio has to be less than 1. So even I don't know any formula, I know that this will not be the answer, because ratio will be less than 1, because this is weaker. So as you know, when all other things are this, pi square EI upon L effective square, and all other things are constant, so it depends on L effective only. So 1 by L effective of this will be L, divided by L effective of this will be L by 2. Okay. L effective of this is L by 2, L effective of this is L. So 1 by L square divided by 1 by L by 2 whole square. Okay, so value is coming to be 0.25, A option. Any doubt here you can ask me. Any doubt you can ask me, guys. Come on. After me, the Chandrasekhar sir will be here. Now, next question. If the length of the column subjected to a compressive load is increased by 3 times to its original length, the critical buckling load becomes, guys, now PCR is equal to pi square E I minimum upon L effective square. In fact, there is N square also. N is the number of buckling loops. In your case, N is 1. In your case, you always study N is equal to 1. Okay, number of buckling loops are 1. But if the column is something like this, so number of buckling loops can be 2 also. So then the formula is 2 square. Then other formula. So in your syllabus, you only study with 1 buckling loop. So you are saying N is equal to 1. That's why you don't study this. Now here, from this formula, you know that PCR is proportional to 1 by L effective square. And length is changing how much? Increased by 3 times. So it will be 1 by 8. Okay, if length is increased by 3 times to its critical buckling load becomes, length is increased pi square EI upon L effective square. So length is increased 3 times. So 1 by 3 into 1 by 3, 1 by 9. Now you will say, sir, it may not be hinged because for hinged L effective is L. Guys, for other also, it is L by 2 or L by root 2 or whatever. L by 2, L by 2 root 2, whatever. So if L is changing by 50%, L effective is also changing by 50%. Whether L effective is L, whether L effective is L by 2, whether it is L by root 2, if it is changing by 50%, L effective is also changing by same percentage. Got it? Got it? Yes, Pechelver, excellent. Now the next question. A square bar of size 10 into 10 mm. Okay. There is a square bar of size 10 mm into 10 mm and length is this. Now it's subjected to a 200 Newton force, tensile. Modulus of elasticity is 200 gigapascal. Modulus of elasticity is 200 gigapascal. Now, what is the strain energy density? What is the strain energy density? Guys, strain energy density means strain energy per unit volume. So, strain energy per unit volume, strain energy density is strain energy per unit volume is area under stress strain graph. Is area under stress strain curve. If you remember, I many times derived this also. Yes or no? So, unless mentioned, we always assume to be material to be homogeneous and linear elastic. Okay. So, how much is the stress? 200 by area. This value, we are applying load up to here. 200 by area. 10 to 10. And corresponding strain will be something sigma by E. Strain is stress by Young's modulus. This sigma by E, that is 200 by 10 into 10 upon 200 gigapascal. I am not converting in units. Units you can convert here. So, if this you will be getting, so the answer you will be getting as, please check, A option. I am not going into the units. Have you got it? Everybody give me yes or no, or otherwise ask doubt here. Why strain energy per unit volume is the area under stress strain curve? Why strain energy is the area under the P delta curve? Everything I told you in the class. You can see my videos of strain energy also. Okay. Now, a solid circular shaft needs to be designed to transmit a torque of 55 Newton meter. If the allowable shear stress of the material is 280, find the diameter. Guys, the maximum shear stress for a solid circular shaft, not for all, is 16T by pi d cube. So d cube is 16T by pi tau max. Pi value you know. Okay, this is tau max. This is T. Everything is given. You have to just calculate this. Everything is given, you have to just calculate this. Everything is given, you have to just calculate this. Can you do this, guys? Keep sharing the video and subscribe the channel for more such sessions. Everybody, everybody, everybody. Okay, now which of the following hardness test uses diamond cone? Diamond cone is used in Rockwell. This is just, you can say, a database question. You have to remember these words. Similarly, for fatigue failure, when you are reversal of loadings, one time here, one time here, one time here, from last times of loading, material deteriorates. That is fatigue failure, and that also happens in the surface like this. Okay, again a database question, material question. Okay, now engineering mathematics, as I am not the perfect one to tell you, so I am just telling you the questions here. You can solve this, and sin mx cos nx 0 to pi, the answer will be 0. Okay, you can write this as sin m plus n cos x plus minus sin m minus n cos x, and accordingly you can do. Now, which this series is? What is this series? Guys, f of x is equal to f0 plus f dash, that means one time differentiation into 0 into x plus double differentiation into x square by 2 factorial plus f triple dash 0 into x cube by 3 factorial plus so on, plus so on. And when you put e की power sin x as fx, e की power sin x is equal to fx, and you apply this, you exactly got this term in just single step. In just single step, you exactly got this term. Okay. Now, the Laplace transform of e a t cos omega t, the answer will be A option. Okay. Now, the curl is asked. Okay. So, curl is I j k del by del x del by del y del by del z into, what is the first coefficient, yz with I, then 3zx, then z, yz plus 3zx and then z. In single step, guys, you can find out that I multiply this, minus j multiply this and this, k del by del x of this minus this, you will be getting A option. I guess this is, you all know. Now, cos z can be expressed as 1 by 2 e की power eta z plus e की power minus eta z. This one, 1 by 2, sorry, this. Now, in a continuous differential function, the gradient of a scalar function, then the curl is, everyone. Okay. 0. Okay. Always in a function which is continuous and differentiable, the gradient of the scalar function, you will do the same steps and it will be coming as 0. Everybody just tell me, have you understood this? Everybody just tell me, have you understood this? Please. Okay, so guys, now there is a workshop tonight at 7:30 PM. Okay. सर आप आज ज्वाइन कर लीजिए. हाँ, कोई दिक्कत नहीं. So guys, now Chandrasekhar sir will be coming. Okay, so he will be taking the other questions from here, and any doubt till then you can ask me. Let me tell you about the cutoff. This is the workshop that will be tonight at 7:30 PM. Civil by Abhinav sir, you can join me. Super Saturday, this cutoff I told you. Now let me tell you the cutoff here also. So guys, the expected cutoff, if I tell you, as Suraj sir also told you, is 68 to 72 marks. out of 100 marks. Okay. For 2023, I am saying number of seats for mechanical are highest. Okay. Number of seats for mechanical are highest, and that will help to all the mechanical students in terms of their selection ratio. Okay. In terms of their selection ratio, it will help. Now, we will be taking more sessions. This is ISRO PYQ 2020. Soon we will be coming with the previous sessions also, so that you can relate with the exam. Everybody on the comment section, just let me know how is the Josh commandos. Okay, okay sir, you can join, you can start stream.
हेलो एवरीवन, ए वेरी गुड आफ्टरनून ऑल ऑफ यू. कैसे हैं सब लोग? एम आई ऑडिबल एंड विजिबल टू एवरीवन? कैन यू गाइज हियर मी? प्लीज रेस्पॉन्ड थ्रू द कमेंट सेक्शन. एंड थैंक यू अभिनव सर फॉर टेकिंग दिस वंडरफुल सेशन और वंडरफुल क्वेश्चंस डिस्कशन ऑन स्ट्रेंथ ऑफ मटेरियल्स एंड मैथमेटिक्स. सो आर यू एबल टू हियर मी गाइज? Please do let me know. I am here with the fluid mechanics questions as well as the thermal engineering, basic thermodynamics and its application. So I want you guys to respond quickly so that we can start our session. All right. So this is my quick introduction for those who are here for the very first time. I am mechanical engineering graduate from IIT Delhi, having more than 10 years of teaching experience. All right. So let us start without any delay. As you all know, Abhinav sir might have already had been told you about tonight there will be a workshop on complete roadmap to conquer GATE 2024 exam. So please do join this workshop and ask your friends also. So the first question on your screen from the hydraulic machines. The first question is from the hydraulic machine. Just hold on. Yes. Read the question and let me know the answer. There is a centrifugal pump having an impeller diameter of 127 mm. D1 is given. Delivers a power of 12 horsepower. P1 is given. If the impeller diameter is changed to 254 millimeter, what will be the power if other parameters are constant? Hi Mithun, welcome. Good afternoon, Pejal world. Please do respond. So you need to develop a relation between power developed and diameter. From the overall efficiency, we can say overall efficiency is power upon rho QGH, isn't it? So power is proportional to Q into H. Rho is constant, G is constant. And we can say power will be proportional to D square into velocity into H. Velocity can be written as proportional to under root of H. So we can say power will be proportional to D square into root H into H. And H to be taken as constant. If we take H as constant, so power will be proportional to D square. This is the relationship which is going to be used to get the value of P2. Can you put the value? Can you make it in equation? P2 by P1 is equal to D2 by D1 square, whole square. There is only one unknown, that is P2. P1 is given, D1 and D2 are also given. What is the answer to this one? What will be the answer? D2 is twice of D1, so 4 times of P1 will be the answer. 4 times of P1, 12 into 4, 48 horsepower. Option A will be the right answer, isn't it? Question number 1, option A. This is the question from the hydraulic machine. Let us move to the next question. Very, very simple, but standard formula based. If you remember the formula for laminar flow, it is laminar flow. In a circular tube of diameter 100 mm and length 13 meter with laminar flow, there is the catch. Fluid mechanics question. The friction factor is estimated to be 0.05. Calculate the Reynolds number. What will be the Reynolds number? If the flow is laminar, there is a relation, standard relation between friction factor, Darcy's friction factor, and the Reynolds number. All right. So can you just let me know what is the relationship? Friction factor is given by 64 divided by Reynolds number when the flow is laminar, when the Reynolds number is less than 2000. So Reynolds number is simply 64 by F. Very simple question. What will be the answer for question number 2? Yes, everyone. Please share your answer. Even if it is correct, incorrect, it does not matter. Because once you make a mistake, then you will understand, you will realize it, and you will not commit the same mistake in your examination ever again. So that is how your mistakes will also teach you to improve your efficiency, improve your performance. All right. So what is the answer for this one? Are you getting 1280? Option C. Yes, Pagal world. Is it Pagal world or Pagal world? C is the right answer. Where are others? Mithun. Formula based question. If anybody is having anything to discuss, anything to explain, you can just let me know through the comment section. The next one, an open tank is filled with water to a height of 20 meter, right? What is the velocity of the water flow at the outlet if the outlet is at the base of the tank? Have you ever heard about Torricelli equation? V is given by under root 2gh. Again, formula based, standard formula based. The velocity is given by under root 2gh that we obtain from the Bernoulli equation applied between the free surface and the bottom. The pressure is PATM at both the places. So all the potential energy is getting converted into kinetic energy. Okay, Pagal. So what is the answer? If you take G, because it is mentioned as approximate, so if we take G as 10, 2 into 10 into 20, then it will be 20 meter per second approximately. The velocity will be 20 meter per second, right? B is the right answer. Yes, Tushar, well done, good, good, good. That is the difficulty level of the question you can expect in ISRO. The question will be very simple, very straightforward. So the most important strategy here to revise all the subjects thoroughly, memorize the standard formula so that you will be able to do the answers, to solve the questions as quickly as possible and as accurately as possible, right? The next one, for a non-dimensional, beautiful question, for a non-dimensional specific speed value of 1 for maximum efficiency, which one of the following turbines is preferred? Most of the students remember the dimensional expression for specific speed of a turbine. N root P upon H to the power 5 by 4. It is a dimensional. It is dimensional. We rarely use the non-dimensional specific speed. Do you guys remember it? So, non-dimensional, dimensionless. If we talk about the dimensionless specific speed, then it will be under root rho into GH to the power 5 by 4. It is dimensionless. It is dimensionless, and that is given as 1. It is given as 1. So if we want to find out N under root P upon H to the power 5 by 4, can we call it as 1 into root rho into G to the power 5 by 4? Do you agree? So this will be the dimensional specific speed in SI unit. Can you put the values and get me the answer? 1 into under root 1000 into, let us take G as 10 to the power 5 by 4. Without calculator, it will be difficult. You can find out the nearest answer if possible. So it will be 10 to the power, it will be 10 to the power, it will be 3 by 2 into 10 to the power 5 by 4. So it will be 10 to the power 11 by 10. It will be 10 to the power 11 by 10. What will be the answer? 10 to the power 11 by 10. Sorry, 11 by 4, not 11 by 10. It is 10 to the power 11 by 4. Sorry, 11 by 4. If you solve it, then you will get your answer something around 562. It is more than 300 in SI unit. You will be getting it at more than 300, isn't it? 10 to the power 11 by 4. So it is greater than 300. You do not need to find out the exact value. You can check if it is greater than 300. It is high specific speed turbine. For specific speed to be greater than 300, it is high specific speed. Then the suitable turbine is Kaplan and propeller, isn't it? Option C will be the right answer for this particular question. I hope this is clear. Any doubt? Anybody is having any doubt? You can just let me know. Yes, they do not want you to find out the exact value, but they just want you to check whether if it is less than 60, if specific speed is less than 60 in SI unit, then the turbine to be installed is Pelton wheel. If NS lies between 60 to 300, then it is medium head, it is Francis. And if it is NS is greater than 300 in SI unit, then it is Kaplan. So you just have to check whether it is less than 300 or is it more than 300. That is how the question will be solved. All right. So let us move to the next one. Next question. An experiment is conducted with a fluid of density 1 kg per meter cube. Right. Velocity as 10 meter per second. The free stream static pressure, that is the free stream pressure, is 100 kilopascal and the local static pressure is 101 kilopascal. What is the pressure coefficient at the location? Pressure coefficient is given by difference of local static pressure minus free stream static pressure upon dynamic pressure, rho u infinity square by 2. Divide by dynamic pressure. This is dynamic pressure. Pressure coefficient is given by the difference of static pressure divided by dynamic pressure of the fluid. Will you be able to get the answer? So this is 101 minus 100, that is 1 kilopascal, divided by rho is 1 into u infinity is 10 square upon 2. What is the answer? 10 square is getting cancelled out with this. So 2 into 10, 20 will be the answer. C is the very nice Pejal. Dukhi Atma, well done. Kahan chale gaye the aap? I was seeing you from that you were there from the beginning of the session. Good, good, good. Hi Rohit, welcome, welcome to the session. Please do solve the questions quickly and accurately. That is what matters the most in the ISRO type examination. This is very simple. This is from basic thermodynamics. In a PV diagram of a steady flow compressor, the intercooling can be represented by, yes, I want you guys to get me the answer. Yes, every one of you. On PV diagram, if I draw PV curve for intercooling, what is intercooling? Intercooling is used for multi-stage compressor. It is constant pressure heat rejection process. What is intercooling? Intercooling is constant pressure heat rejection because it is constant pressure process. Constant pressure heat rejection. If it is constant pressure heat rejection process, then it will be horizontal line. It will be horizontal line. The curve will be something like this. This is compression, isentropic compression. Then this is This is intercooling. And then again another compression. 2 to 3 is intercooling. Intercooling. Right? So it is represented by a horizontal line. Yes, Tushar, well done. Pejal, Dukhi Atma, good, good, good. कहां से लेके आते हैं ऐसे नाम आप लोग? Which of the following is a non-Newtonian fluid? What is non-Newtonian fluid? Which do not obey Newton's law of viscosity. That is non-Newtonian fluid. Yes, what is the answer? People might be having a question or doubt in gasoline. Which one of the following is a non-Newtonian fluid? Question from FM. Gasoline, water, air, honey, all are Newtonian fluids. All are Newtonian fluids. Gasoline is also Newtonian fluids. Newtonian fluids. Tau is directly proportional to du by dy. This is the Newton's law of viscosity. They follow. D is the right answer. None of the above is a non-Newtonian fluid. All right. The next one, from the thermodynamics again, a hot body at 1000 Kelvin, there is a hot body of 1000 Kelvin, transfers 2000 kilojoule of heat to a body at 500 Kelvin. What is the net entropy change? There is a decrease in entropy for the hotter body and there is an increase in entropy for a cooler body. Temperature remains constant. So can we say change in entropy is equal to minus Q by T1? There is a decrease in entropy. Plus, because heat is added to temperature T2, so Q by T2, put the value, you will get the answer. So Q 1 upon T2, 500 minus 1 upon T1, that is 1000. What is the answer? Q is 2000. So 2000 into 1 upon 1000 plus 2 kilojoule per Kelvin. Plus 2 kilojoule per Kelvin. Yes. Plus 2 kilojoule per Kelvin. This will be the formula for change in entropy. For this system, it is an isolated system. The next question. Highest ratio of specific heat, gamma. Ratio of specific heat is gamma, Cp by Cv. Do you know? Gamma for monoatomic. Gamma for monoatomic gas is 5 by 3, that is 1.667 something. Gamma for diatomic is equal to 7 by 5, that is 1.4. Gamma for multiatomic 4 by 3, isn't it? That is 1.33. So for monoatomic gas, gamma is maximum. Gamma is Cp by Cv ratio. So argon is monoatomic, helium is monoatomic, hydrogen is diatomic, air can also be taken as diatomic because nitrogen is in bulk quantity. So A and B both will be the correct answer. Yes, Tushar, well done. A and B both can be taken as the right answer because both are monoatomic gases. Both are monoatomic. And these are diatomic. So option A and B both can be treated correct for this question. Shall we proceed further now? Shall we proceed further? Anybody is having any doubt? You can just let me know. It is theoretical question, but you should understand the significance of each and every relationship here. Yes. Which one of the following can be used to determine the variation of saturation pressure with the temperature along phase boundaries? So we need to have the relation between saturation pressure and saturation temperature, which is the relationship is used to develop a relation between saturation pressure and saturation temperature. It is Clausius-Clapeyron relationship. dP by P saturation is given by HFG upon R into dt by T square saturation, isn't it? This is how we can relate P saturation with the temperature. D will be the right answer for the given question. It is again from basic thermodynamics. Let us move to the next one. This is question number 10. This is question number 11. I am having around 18 questions in total. We are at question number 11. And after me, Suraj sir will be taking over the charge and he will be going to discuss the questions from the heat transfer, industrial engineering and engineering mechanics. I think these are the only left out subjects. Rest of the subjects have already been completed by Dheeraj sir and Abhinav sir. And I will be going to complete fluid mechanics and thermodynamics and its applications. All right. Thermodynamics is very, very important along with its application in case of ISRO examination. So you should revise each and every topic thoroughly so that you will be able to get the best possible score. It is a golden opportunity. Do not leave it. Try to grab it. Try to give your full effort to grab this opportunity. All right. So the next question on the screen, question number 11. I will take 10 minutes more, 10 to 15 minutes. Then I will invite Suraj sir to start his part of discussion. Air at 27 degrees Celsius, 100 kilopascal enters in a steady flow. What is a steady flow? For a steady flow, mass flow rate remains constant to a nozzle at a velocity of 100 meter per second. That is the velocity C1. If the inlet area of the nozzle A1 is given, what is the mass flow rate through the system? Mass flow rate is given by rho1 A1 into C1. How to calculate rho1? By using the ideal gas equation. So mass flow rate is P1 by RT1 into A1 into C1. C1 is the velocity actually. In case of thermodynamics, we use the notation C for velocity because V is used for specific volume. That is why we are using a different notation. What is the answer? Yes. Did you solve it? Are you getting option C? Well done. Well done, Dukhi Atma. Good, good. What about the others? So mass flow rate is P1 is 100 into 10 to the power 3. Take care of the unit. R is 0.287 for air in kilojoule into 10 to the power 3 joule into T1. Temperature should be taken in Kelvin. 273 plus 27, that is 300 into area A1 0.5 into velocity 100 meter per second. If you solve this, then you will get the answer to be 58 kg per second. Are you guys getting 58 kg per second? Yes. Can we proceed to the next one? This is memory based question. Critical point of water. How many of you remember? How many of you remember this? Critical point of water. What is critical point? Critical point is temperature and pressure at which all the three phases of a substance coexist in equilibrium. What is critical point? I was talking about triple point. Critical point is the temperature and pressure at which liquid and vapor phase becomes identical. Liquid and vapor phase becomes identical. There is a difference between critical point and triple point. There is a difference between. If we talk about critical point of water, the pressure is 22.06 megapascal and the temperature will be 373.95 degrees Celsius. Right? These are the critical point, temperature and pressure. Triple point, the temperature and pressure at which all the three phases coexist in equilibrium. coexist in equilibrium. So the triple point temperature for water, is 0.01 degrees Celsius or 273.16 Kelvin, and the pressure, triple point pressure, is 611.73 Pascal. So these are the triple point temperature and pressure. It is megapascal. Critical point pressure for water is 22.06 megapascal. These are the standard value for water. You should remember. This is for water, right? So B is the right answer. Critical point where liquid and vapor phase become identical, and triple point is where all the three phases of a pure substance coexist in equilibrium. The next one, question number 13. The next question on your screen. In a shower mixture, cold water at 27 degrees Celsius flowing at 5 kg per minute is mixed with hot water at 77 degrees Celsius flowing at 15 kg per minute. That's the temperature of the mixture. There are two fluid streams, 1 and 2. They are getting mixed and the final stream is third. The exit temperature. We need to find out T3 in degrees Celsius. So according to energy equation, if we write energy balance equation, we can say M1H1 plus M2H2 is equal to M3H3, isn't it? Or per unit time we can say mass flow rate, mass flow rate, mass flow rate. So M dot 3 will be equal to, from the mass conservation, M dot 1 plus M dot 2 is equal to M dot 3. So M dot 1 is 5 kg per minute. H1, that is Cp into T1, plus M dot 2, that is 15 kg per minute. Then Cp, specific heat of water, into T2 is equal to M1 plus M2, that is 20, 15 plus 10, 15 plus 5 into Cp into T3. T3 is to be calculated. Cp getting cancelled out. So 5 into what is the temperature T1? T1 is 27 degrees Celsius plus 15 into what is the temperature T2? T2 is 77 degrees Celsius is equal to 20 into T3. You can easily solve for T3 in degrees Celsius. You will get your answer in degrees Celsius. Your answer will be in degrees Celsius. What is the answer for question number 13? What will be the answer? Are you getting 64.5? 64.5 degrees Celsius. So guys, you should be ready, or you should be ready to do hard work. We are there to help you out in every possible way. So we will be bringing every day the question practice or the previous year questions for ISRO examination. So if you are ready to do hard work, we are there to support you, help you out in every possible way so that you crack the ISRO examination with flying colors. Which of the following uses a regenerator? Which of the following uses a regenerator? What is regenerator? What is the regenerator? It is the periodic contact heat exchanger. It is used to decrease the heat supply, QS decreases, and by using the regenerator, efficiency increases. So in Ericsson cycle and Stirling cycle, in these two cycles, regeneration is used because they are isothermal processes. They are isothermal processes. They involve the isothermal processes. So regenerator is used in Ericsson and Stirling cycle, both B and C. Regeneration is used in both B and C. If there is a regenerative erection and stirring cycle, then the thermal efficiency is same as Carnot cycle, is equal to Stirling is equal to erection. Erection cycle involves constant pressure processes, 2 constant pressure and 2 isothermal processes. Stirling cycle involves 2 constant volume process and 2 isothermal processes. So with regeneration, the efficiency becomes maximum, that is equal to the Carnot efficiency. So erection and Stirling both involve the regeneration, or there is a heat addition which is taken from the heat by the outgoing fluid from the turbine. This is the question from the mass transfer. This question is from the mass transfer. Ratio of convective mass transfer to the mass diffusion rate is called as. Standard question. If you know it, you will be able to get the answer. Otherwise, you may not. The ratio of convective mass transfer to the mass diffusion rate. Mass diffusion rate is similar to conduction, and convective mass transfer is like mixing or convection. So this ratio is called as Serwood number. Do you remember it? Right. Couple of more questions. Couple of more questions. 3 questions are left with me. Then I will invite Dukyatma. That is different. Nusselt number is for convective heat transfer. Convection upon conduction, but they are similar to conduction and convection. But for mass transfer, it is Serwood number. Yes. So let us invite, or let me check with Suraj sir if he is there. And let me show you the next question. Please try to solve this one. Meanwhile, the next question on your screen. A gas is contained in a cylinder with a movable piston of 100 kg mass. When 2500 joule of heat flows into the gas, it is from the basic thermodynamics or first law of thermodynamics, that is energy conservation law. 2500 joule of heat flows into the gas. The internal energy changes by just hold on. Yes. This is the piston cylinder arrangement. 2500 joule of energy is added. Then the piston rises like this. What is the distance by which piston will rise? And there is a change in internal energy by 1500 joule. So from the first law of thermodynamics, we can say heat added is equal to change in internal energy plus work done. So this is 2500, this is 1500 plus W. So work done is equal to W is equal to 1000 joule. W will be equal to 1000 joule. So work is done by the system to move the piston. So work done is equal to, it is against the weight of the piston. So work done is equal to weight of the piston multiplied by the distance x. What is the weight of the piston? M into G into x. So work done is 1000. M is mass of the piston is 100 kg. Let me take G as 10 into x. So x is equal to 1 meter. 1 meter. Isn't it? The next one. The next question. This question involves the concept of thermodynamics as well as heat transfer. thermo plus heat transfer. A refrigerator with COP of 5. A refrigerator of COP of 5. This is Q2, this is Q1, this is W input. COP for a refrigerator is given by Q2 upon W, that is Q1 minus Q2. And if it is an ideal refrigerator, Carnot refrigerator, then COP will be equal to T2 upon T1 minus T2 for reversible refrigerator. Is used in a room at 300 Kelvin. So this is the room temperature. T1 is the ambient temperature. So T1 is given as 300 Kelvin. T1 is given as 300 Kelvin, isn't it? What will be the heat intake through a section of refrigerator wall of area this with a thickness, assuming only conduction, value of thermal conductivity of the wall can be taken as 1 watt per centimeter Kelvin. I think here there is a mistake. So it is 100 watt per meter Kelvin. 1 centimeter should be converted into watt. So from here we can find out the value of T2. Can you find out the value of T2? So COP is given as 5 is equal to T2 upon 300 minus T2. Can you find out the value of T2? Are you getting 250 Kelvin? T2 will be 250 Kelvin. So here there is 300 Kelvin temperature, here there is 250 Kelvin temperature, and the thickness is given. So the rate of heat transfer is K into A into delta T by L. Thermal conductivity is 100, area is 100 centimeter by 100 centimeter, 1 into 1 into delta T, 300 minus 250 divide by 100. What is the answer? Divide by not 100, divide by thickness. What is the thickness? 10 centimeter, that is 0.1. So your answer should be 50,000 watt. Are you getting 50,000? Are you guys getting 50,000 watt? So neither of them is correct answer for the given parameters. None of them is correct. None is correct. None of them is correct. Because it will not be 5,000, it will be 50,000. Are you guys getting 50,000 watt or not? Q will be 50,000. So for the given parameters, none of the options will be correct. Are you getting it? Is this clear? So the last question from my side, a mass of 1 kg of air at 27 degrees Celsius and 0.98 atmospheric pressure is taken through a diesel cycle. If the compression ratio, what is compression ratio? R, that is V1 by V2. The volume before compression to volume after compression is given by 16. Calculate the temperature of the air after compression. 1 to 2 is isentropic compression. In a diesel cycle, 1 to 2 is isentropic compression. 1 to 2 is isentropic compression. So T2 by T1 is equal to P2 by P1 to the power gamma minus 1 by gamma, or we can write it as V1 by V2 to the power gamma minus 1, isn't it? And gamma should be taken as ratio of specific heat should be taken as 1.5. So T2 is equal to T1. What is T1? T1 is 300 Kelvin into V1 by V2, that is 16 to the power 1.5 minus 1, that is 0.5. So 16 to the power 300 into root 16. Root 16 is 4. So 300 into 4. 1200 Kelvin. What is the answer? T2 you will get 1200 Kelvin. It is not A which is correct. So 1200 minus 273 degrees Celsius will be the value of T2. What is the answer? Subtract 273. So 927. So do not commit mistake in the units. Sometimes you might end up committing mistakes in the units. or the basic mistakes, silly mistakes you should always avoid in the competitive examination. So guys, that is all from my side. I hope you enjoyed it. Please do stay in touch so that we can bring more such session for your benefit. Now, I would like to invite Suraj sir for discussing his part of the subjects. All right. Thank you guys. Thank you very much. See you in the next session.
Hello, very good evening. Good afternoon, guys. Welcome to BYJU'S exam prep. Very good afternoon. I hope everything is good with audio and video. Please do let me know in the comment section. All good, all perfect. Because now we're gonna solve some very basic questions from the your industrial engineering, heat transfer, and engineering mechanics. So to tell me, is all good? Hello, aspirant. Not audible. Am I not audible? Yes, everyone. Okay, 1 second. Let me check. Now, I think that is quite okay. Yes, aspirant, pagal word. I think what unique name we are having. Now it's all good. Okay, fine. Chalo, let's quickly start off the session, right? And so that we can cover up all the question. Okay, so now still low. I think it won't be low. I've just increased my volume from my side. Still you are having, we can have some, okay, all good, fine, chalo. Okay, so I hope so you have seen this workshop today, like 26th of, today, like 26th of May, 7:30, Abhinav sir will be coming live. So I think all good. So I'll be discussing the questions from all the three topics that you are seeing on the screen: the industrial engineering, mechanics, and your heat transfer. Now, if I talk about ISRO perspective, heat transfer is an important subject because 7 to 8 number of question is being expected. Industrial is a very easy 1 or 2 question. Mechanics also 1 or 2 question they are asking from this particular subject. So let us, without wasting the time, let's start. Are you ready? All good? All perfect? ISRO 2020, last few questions left out. First question, I think this is already been discussed by Chandra sir. So let's have a quick recap. The ratio of convective mass transfer to the mass diffusion rate. What do we call this one? I think this was already discussed by Chandra sir, so you will be able to answer it very easily. The answer for this is related to the mass transfer. Okay, so exactly option A is the correct answer. Sherwood number. What is Sherwood number? Anyone? It is nothing but the ratio of convective mass transfer to the diffusion rate. But what about Schmidt number? What do you mean by this? Level of question is similar. This is exact. This is a previous year question. This is a last like 2020 paper of ISRO. Okay, so you'll be having an insight how level, what is the level of question. If I talk about Schmidt number is nothing but your kinematic viscosity to molecular diffusion. Rayleigh number, you know, it's the product of Gyroscope into Prandtl. Now, what is Strouhal number? Anyone? What is Strouhal number? Has anyone heard about this? This is basically we are using in computation fluid dynamics. Okay, and that is nothing but we are using a very simple formulation, F into D by velocity. F stands for the vortex shedding frequency, D is diameter of the cylinder, and V is the velocity of the fluid. Okay, slightly which is not there in your syllabi, so you might not have heard. This is a topic, or this is a number that we are studying in computation fluid dynamics, especially in PG, like in masters we are studying this particular number, not in bachelor's program. Okay, so Rayleigh number, you know, Schmidt number we have discussed, Sherwood number. So next question on the screen is from heat transfer. Let's see who will be giving me the answer. The external surface of the wall of 3 meter height. Let us try to draw the diagram. There is a wall having a height of 3 meter, 5 meter width, and a thickness of 0.5 meter. Okay, thickness of 0.5 meter, right? And the temperature is 2 degrees. So let's suppose this is T2, this is T1. Heat loss is 150 watt from the room is measured. Find the inner temperature. So they're asking what's the inner temperature. T1 they're asking, T2 they're giving as 2 degrees Celsius. And the thermal conductivity K value is 1 watt per meter Kelvin. Very easy question. You have to use the Fourier's law. It's a one-dimensional heat conduction equation because the heat is flowing through the cross section of the wall. Okay, you have to calculate the inner temperature, outer temperature, that is already given as 2 degrees Celsius. So can you tell me what's the value of T1? Simple. electrical analogy, if you try to draw the circuit diagram, we'll be having T1, we'll be having T2, this will be L by Ka, this will be your heat transfer, that is Q. So I can simply say Q is equal to K into A into delta T by L. Okay, Q is 150, K is 1, area. Now can you tell me what area we have to take? Anyone? What area we need to take? Do you take 0.5 into 3 or 0.5 into 5 or 3 into 5? We always take the cross section area. We'll be taking this area, right? What is this area? This is nothing but 3 into 5, the cross section perpendicular to the direction of heat flow. Okay, so 3 into 5 will be the area. T1 we need to calculate, T2 value is 2 divided by the thickness is 0.5. So solving this, it is 150 is equal to 3 into 5 into T1 minus 2 divided by 0.5. So what's the value of T1 quickly? I don't think so. You should be taking much time. Very good. दुखी आत्मा यार, बहुत ही unique नाम रखा आप लोगों ने. दुखी आत्मा, पागल word. We are having unique names today. So T1 is equal to 2 plus 15 into 5 by 3 into 5. This is 7 degrees Celsius. Okay, fine. So they're asking in Kelvin. So plus 273, that is 280 Kelvin is the final correct answer. Option A. Option A. 7 degrees Celsius is the answer that we are getting. 280. Very good, Shaker. Very good. All the unique names we are having. Chaliye. Is this clear? All good. Can we go with the next problem? बहुत दुख है यार. देखो दुख में क्यों रहना, जब देखो ऊपर वाला कभी ना कभी यू हैव गिवन योर बेस्ट, आप मेहनत कर रहे हो तो ऊपर वाले एक बार तो कभी ना कभी देखेगा. एंड दे हैव सीन इसरो को यार अच्छा वैकेंसी आया. लाइक इफ यू ट्राई टू कंपेयर विद अदर ब्रांचेस, हमारा जो वैकेंसी है 3 डिजिट में है. सो दैट इज अ गुड नंबर. ट्राई टू ग्रैब दैट अपॉर्चुनिटी, राइट. तो दुख देखो सबके जीवन में दुख होता है. सो डोंट वरी अबाउट दैट. ओके, दैट डिपेंड्स अपॉन, इट्स अ रिलेटिव टर्म, राइट. Okay, the typical range of Prandtl number of for water is, what is the range of, that's a simple database question है. पूछ रहा है what is the Prandtl number for water 0.004 to 0.3, 1.7 to 13.7, 50 to 500 or 2000 to 1000. अब देखो, we know that the Prandtl number of water is always near about to 1. 1 से ज्यादा, it is always greater than 1 but near about to 1. So that will be giving us option B as a correct answer. Okay, there are some standard values we need to remember. Just if I talk about your Prandtl number for air, the Prandtl number for air is near about 0.71, something in this range. Something in this range we are having the Prandtl number. तो कभी कभार ना इसरो में they are asking the database question like this. It won't be a difficult one. ठीक है, जैसे thermodynamics they might be asking about the critical temperature, okay, or triple point, right? So you can get some direct straightforward question. Exactly. Very good. Very good. चलिए next question. यार ये तो बहुत easy. This is a very easy question. A fluid having a density of 1 gram per centimeter cube in a state of in a state with Gyroscope number 2 into 10 to the power 6 and Prandtl number equal to 0.7, assuming the acceleration due to gravity as 10 meter per second square, what is the Rayleigh number? Chalo, simple question. I don't think so for solving this question any calculator is required. ऐसे question में 5 seconds maximum time limit should be given. They're asking the value of Rayleigh number. What is Rayleigh number? It is a product of Gyroscope into Prandtl, right? So what is Gyroscope? That is 2 into 10 to the power 6 into 0.7. This will be 1.4 into 10 to the power 6. Option is the correct answer. Very good. Very good. Absolutely correct. बहुत बढ़िया, बहुत बढ़िया, बहुत बढ़िया. Clear है? Yes, 1.4 into 10 to the power 6 is the Rayleigh number. Okay, चलिए आगे बढ़े. Now tell me, is this a laminar or turbulent? Anyone? Is this a laminar or turbulent? कोई बता सकता है? Anyone who can tell me in the comment section? The type of flow by looking at the value of Rayleigh number, because Rayleigh number is acting similar to that of, it's an analog to the Reynolds number. Reynolds number forced convection में Rayleigh number we are using in the free convection. And if you have seen that, if the Rayleigh number is less than 10 to the power 11, that is your laminar flow. तो ये तो 10 to the power 6 है. Okay, if your Rayleigh number is less than 10 to the power 11 in that particular range, that is a laminar flow, और उससे ज़्यादा it's a turbulent flow. Okay, next question on your screen. A cold liquid enters a counterflow heat exchanger at 15 degrees Celsius at a rate of 8 kg per second. A hot stream, so we are having a cold fluid. Let's write the data. Cold fluid है, जो it is entering at 15 degrees Celsius. Okay, and the mass flow rate of the cold fluid is 8 kg per second. Now, if I talk about hot fluid हॉट फ्लूइड की बात करते हैं. हॉट फ्लूइड एंटर्स एट 75 डिग्री सेल्सियस and the mass flow rate of the hot fluid is 2 kg per second. Assuming the specific heat for the fluid as 4 kilojoule per kg Kelvin. So C value, C is equal to CH is equal to CC, that is equal to your CPC CPH ये आपका आ रहा है 4 kilojoule per kg Kelvin or degree Celsius, one of the same thing. Sir, age relaxation is not available requirement. Age relaxation is not available requirement. Option D. Okay, very good. अच्छा बताइए what's the answer for this? Very easy question. A, B, C or D? Very easy question. 1 second guys. Quickly. Option A, option B, option C or option D. देखो 5 to 10 minutes में we'll be winding up the session. Okay. So here we can calculate, they're asking what's the maximum heat transfer rate. So Q max you have to calculate, that is equal to C minimum into the maximum temperature difference, that is THI minus TCI. So this is equal to, now if I try to visualize, आपका hot fluid का mass flow rate is less, so that will be CH into THI minus TCI. Okay, so that is equal to M dot H CPH into THI minus TCI. तो कितना है? That is 2 into 4. THI is 75 minus 15. What's the value? 8 into 60. 8 into 60. Exactly. Age relaxation. हाँ नहीं देखो, I don't think so. I need to check with that age relaxation. ठीक है. हो सकता है they are availing. OBC is also have maximum. Okay, so 480 kilowatt. तो वो एक बार चेक करना पड़ेगा. Age relaxation I have not seen Sahu. Okay, 28 normally 28 is the maximum age limit for maximum PSUs. अगर मैं ONGC की भी बात करूँ, that is a PSU that is hiring till 28, but बाकी PSUs 26 is the last threshold limit. 25 to 26 is a age limit for many PSUs through gate examination. तो make sure अगर आप 25-26 पे तो जल्दी से full मेहनत करके you have to go for that. 480 kilowatt is a correct answer. चलिए next question. The temperature of a surface of 0.2 meter square area at 17 degrees Celsius. Calculate the wavelength corresponding to the maximum monochromatic emission power. Quickly. CBT होता है यार, computer based test. Aspirant, it will be a computer based test only. चलिए quickly. आपको निकालना है what is the value of the wavelength corresponding to the maximum power, and they are giving you the temperature. So temperature को we have to convert. This is 273 plus 17, that is equal to 290 Kelvin, right? So we can say lambda into T, Wien's displacement law we have to apply 2898 micrometer Kelvin. So this is equal to lambda, we have to calculate 2898 divided by 290. So approximately 9.999 something micrometer will be the value. तो हम लोग लिख सकते हैं 10 micrometer. So option C is the correct answer. Yes, option C, 10 micrometer is the final correct answer. Okay, approx 10. Normally you can take this as 2900 also. We can take it like this, lambda m into T is approximately equal to 2900 micrometer Kelvin. ऐसे भी लिख सकते हैं, तो उससे आपका exact 10 आ जाएगा. If you are taking 2900, then your option C will be the exact value, but we don't have to go for any approximation. 2898 be on a safer side. Okay, fine. So 9.999 something. So option C is the correct answer, 10 micrometer. चलिए next question. Next question is slightly interesting. ठीक है, let's read out the problem. For a surface, the direct and diffuse components of the solar radiations are 400 and 300 watt per meter square. The direct radiation makes an angle of 60 degree angle with the normal. If surface temperature is 300 Kelvin and effective sky temperature is 200, what is the net rate of radiation heat transfer? Assume the solar absorptivity and emissivity as 0.11 E. Take Stephen Boltzmann constant as 6 into 10 power minus 8 for easy calculation. चलिए, try this problem. Now it's quite easy. They are asking what is the net heat transfer or net heat exchange or net rate of radiation heat transfer. So what we can do, what is the total amount of heat that is being absorbed by the surface and what is the total amount of heat that is being reflected by the surface? That's all we have to calculate. Okay, so let us first of all calculate the diffuse right, we can say the energy of diffuse, the diffuse energy, the diffuse radiation that they have given is equal to how much? 300 watt per meter square. Now, over here we can say this direct radiation, it's making an angle of 60 degree with the normal. So we can apply the Lambert cosine. We can apply the Lambert cosine. So we can say direct radiation, okay, or direct radiation will be equal to your 400 cos of 60. If you remember, if this is your direct radiation, right, making an angle of 60 degree with the normal, so we can apply the Lambert cosine law. So this will be 1 by 2, that is 200, okay, 200 watt per meter square, right? So we can say what is the total incident on the surface? Total incident radiation. Total incident radiation, that will be equal to alpha times 200 plus 300. What is 200? What is alpha? That is 0.1. 0.1 into 500, that is 50 watt per meter square. Okay. Now we have to identify what is the total emission. What is the total emitted radiation? Emitted radiation, that is equal to your sigma into this T1 to the power 4 minus, or surface to the power 4 minus your ambient, right, or sky to the power T1 minus T2 power 4. Chalo, T1 minus T to the power 4. Okay. So this is 0.1. I think they have given us 0.1. Alright. 6 into 10 to the power minus 8. So this is your temperature is 200 and 300 Kelvin. So this will be 300 to the power 4 minus 200 to the power 4. What's the value you are getting? Somewhere approximately. What's the value of total emitted radiation? Anyone? If you try to calculate, it should be somewhere around 39 watt per meter square, which I have calculated. 39 ke around aana chahiye, right? So they're asking what's the net rate of radiation. So we can say net rate of radiation, that is equal to the change. So total incident is 50, this is 39. So 50 minus 39. So somewhere around we can say 11 watt per meter square. Are we getting 11? 11, option A, 11 watt per meter square. aa raha hai? Bahut badhiya, very good. Okay, so net amount of radiation that, or that amount of radiation heat transfer that is happening will be 11 watt per meter square. हमें कुछ करना है, जितना absorb हुआ है, जितना leave कर रहा है, what is the net emission? So total change that is being getting, that is your net rate of emission. Very good, very good. Option is the correct answer. चलिए next problem on the screen. From a question from industrial, एक ही question आया, नहीं sorry, एक ही question आया from industrial. Only one question from industrial engineering. A dummy activity is used in PERT network to describe. And if you remember, this was the same question that was repeated in engineering service also. So ESE से भी ना कभी कभार direct question is being repeated. Okay, so you can do practice apart from previous year question of ISRO. You can practice some ESE questions also. Option A, absolutely correct. The dummy activity we are using in order to prevail the relationship, right? And that dummy activity is not taking any resources, it's only for the logical sequence, for logic ko prevail karne ke liye. That's it. Option A is the correct answer. Next question from the engineering mechanics. Okay, a screw jack of lead angle alpha, what is the effort required to lift the load W is given by? So what is the answer? They're directly straightforward question they are asking from the screw jack mechanism. Okay, the application of friction, you might have studied in engineering mechanics, आपने पढ़ा होगा, simple सा formula based question है. What is the answer? So we can say the effort required will be equal to W tan phi plus alpha. ठीक है, where phi is the friction angle, alpha is the helix angle or lead angle, right? So phi plus alpha, option B is the correct answer. Cos तो कभी होता ही नहीं है. If you try to remember, cos is never ever applicable to this. Option B. ठीक है, fine. चलिए next question. 3 question थे from your mechanics topic. Now if you try to solve this, it's a very easy question. Two trusses XY and YZ are identical size. Please make sure they are saying identical size. Supports a load of 200 Newton. The length of the truss is 1 meter. The force in the truss XY in Newton is. Simple question. यहाँ आपका 200 है. This is 200. Okay. This is your T YZ. This is your T XY. Right. So question is एग्जैक्टली बट क्या मैं साइन रूल लगाने की जरूरत है? व्हाट विल बी दिस एंगल? व्हाट विल बी दिस एंगल? एनीवन? दिस इज नथिंग बट 120. This is 120, right? This is also 120. This is also 120, right? So can we say अगर 120 each angle है और ये 200 है, t x y and y z they are equal length, can we say ये भी 200 होना चाहिए, ये भी 200 होना चाहिए? Yes, है ना? ये भी 200 होना चाहिए, ये भी 200. Then only the equilibrium condition will be prevailing. तभी तो equilibrium condition होगा. Okay, so option B is the correct answer. Even if you want to apply the Lami's theorem, you can apply the Lami's theorem. Lami's theorem को apply कर सकते हैं. We can apply 200 divided by sine of 120 is equal to txy divided by sine of 120 is equal to tyz divided by sine of 120. Because x and y being identical, so definitely we can say the each and every member will be having 200 Newton of force. Okay, exactly. You can go for the resolution also. You can go for the Lami's theorem, whichever you are feeling comfortable. Last question, guys. Last question from the engineering mechanics. Then we are winding up the session. A very we can say easy question from the friction topic. A block weighing 100 Newton is resting on a plane inclined with a horizontal as shown in the figure. What should be the horizontal force P necessary to hold this body from sliding down? We can take the coefficient of friction to be 0.25. कोएफिशिएंट फ्रिक्शन हम लोग 0.25 हम लोग ले सकते हैं. चलिए जल्दी बताइए व्हाट विल बी द वैल्यू ऑफ हॉरिजॉन्टल फोर्स. चलो रिजॉल्व करते हैं. लेट अस ट्राई टू रिजॉल्व दिस. लेट अस से दिस इज आई एम टेकिंग थीटा एज 45 डिग्री. ठीक है, थीटा मैं 45 डिग्री को आई एम टेकिंग एज थीटा. सो दिस विल बी थीटा, राइट? दिस विल बी, सो इफ आई ट्राई टू ड्रॉ द FBD, so this is your normal reaction. Let me do one thing. Let us draw it over here. यहाँ पे ड्रॉ कर देते हैं for easy calculation. Okay, so this is a normal reaction, right? This will be P cos theta, this is P sin theta, right? Okay, W आपका, this is your W cos theta and this is your W sin theta. Now tell me what will be the direction of friction? बस ठीक है, last question. What will be the direction of downward or upward? Now the body is tending to slide down, so I can say the direction of friction will be upward. This is your direction of friction, that is upward. Okay, so we can go for the total horizontal force and vertical force to be equal to 0. So I can say total vertical force equal to 0. So normal reaction will be equal to W cos theta plus P sin theta, right? And if I talk about the total horizontal force equal to 0, I can say P cos theta plus F is equal to W sin theta. Now I can say P cos theta plus mu times N is equal to W sin theta. So I can write it over here. So P cos theta plus mu, N is basically W cos theta plus sin theta. W cos theta plus P sin theta, right, is equal to W sin theta. We have to calculate the value of P, है ना? P की वैल्यू निकालनी है. So P is equal to W sin theta minus mu W cos theta divided by cos theta plus mu sin theta. Okay. Yes, definitely. So P is equal to, now we'll be having frequent classes, sin theta minus mu cos theta, right, divided by cos theta plus mu sin theta. Now if you try to visualize here, the theta value is nothing but this angle will be 45. Okay, here also this angle will be your W cos theta, this is 45. So can we say sin 45 cos 45 will be cancelling out, so ultimately we were having W into 1 minus mu divided by 1 plus mu, क्योंकि theta is equal to 45 degree, है ना? अगर theta 45 है, sin 45 cos 45 cancel out हो जाएंगे, then we are left out with this. Now question becomes very easy. W is equal to 100, okay, 1 minus 0.25 divided by 1 plus 0.25, so this is 100 into 0.75 divided by 1.25. What's the value you're getting? This is 3, this is 5, this is basically 5 we are having, है ना, SQ लिख दिया मैंने. Okay, 5, this is 20, so 60 Newton we are getting. Yes, are we getting 60 Newton? Okay, so 60 Newton, option C is the correct answer. Fine, 60 Newton we are getting. So this is the complete paper of ISRO. We have discussed in detail every single question with explanation. It's not like this कि भाई ऊपर ऊपर से just ये answer, ये answer, ये answer. That's it. Okay, fine. So this is it from my side. I hope so. And we are also providing some free ebooks. Try to download that. The description is there in the comment section, right? And also your scholarship test will be soon conducting. For that, link is being provided, and also for the workshop. Okay, so every Saturday will be coming up with very important informative video regarding Know the Legend and Raftar. I hope so you know about this already. आपने इसके बारे में देखा होगा. This is my personal Telegram channel. और let's try to take some doubts. Then we'll be winding up the session. Sir, allied part में कौन सा subject include होगा exam में? Allied part में देखो यार, देखो maximum weightage they have clearly mentioned from the mechanical. ठीक है? If you see आपके 80 क्वेश्चंस होंगे यहाँ से और 20 क्वेश्चन होंगे आपके सेक्शन बी से. ठीक है? वेरी इजीली यू कैन कैलकुलेट, वेरी इजीली यू कैन स्कोर. 80 + 20 है और उसमें जो 80 में भी जो है दैट यू कैन इजीली सिक्योर. उसका भी आई थिंक मी और धीरज सर, आई थिंक ही हैज गिवन अबाउट द एनालिसिस, वेटेज एनालिसिस आल्सो. ठीक है? अगर नहीं है तो आई हैव ऑलरेडी टेकन वन सेशन ऑन दैट आल्सो. आप उसको भी देख सकते हैं, द प्रीवियस ईयर एनालिसिस. बट इस ईयर they have slightly changed some we can say exam का pattern थोड़ा सा change हुआ है. Not exactly the same, 80 questions है, but now they are having only 1 marks each. ठीक है? और questions का level definitely थोड़ा सा कम हो सकता है, right? Not more than that. So thank you guys. I hope you all enjoyed, and do stay connected because tomorrow also will be coming live at 11 AM. Same आज 2020 का था, अब 2018 का paper will be discussing tomorrow at 11 AM. Okay, fine. Thank you Zahu, thank you Shekhar, thank you पागल वर्ड, दुखी आत्मा जितने लोग हैं. Don't be दुखी, चलो कोई प्रॉब्लम नहीं है, but try to be concentrate for the next 2 or 3 months. Try to give your best because ISRO actually has given you a golden opportunity. Okay, so thank you, stay connected, and do share this video to all of your friends. Thank you guys, bye bye, take care, stay safe, bye bye.